When a generator system is required to supply power to a fire pump, it becomes classified as a legally required standby system, or LRSS, according to the National Electrical Code, specifically Section 700.9 DAN. This classification triggers specific requirements related to fire protection. The NEC mandates that a legally required standby system be installed within a 2-hour fire-rated room. This fire-rated enclosure is designed to protect the generator, the automatic transfer switch, or ATS, and any other associated equipment from fire damage, ensuring that the system can continue to operate during an emergency. All wiring associated with the legally required standby system must also be protected by 2-hour fire rating. This includes the wiring within the fire-rated room as well as the wiring that extends outside the room to supply power to the fire pump and other legally required loads. The fire-rated wiring ensures that the circuits remain operational even in the event of a fire. To ensure the reliability of the fire pump, it is crucial to connect it to the line side of the generator main. This means that the fire pump is supplied with power directly from the generator output before any other loads. This arrangement guarantees that the fire pump receives uninterrupted power regardless of the status of other generator loads. It is also recommended to use a separate transfer switch that is specifically listed for fire pump applications. Fire pump transfer switches are designed to handle the high inrush current associated with starting a fire pump motor, also known as the locked rotor current. This ensures that the transfer switch can reliably transfer power to the fire pump when needed. While it might seem intuitive to add a second main breaker to the generator to isolate the fire pump circuit, it is not generally necessary. Connecting the fire pump to the line side of the generator main already provides the required redundancy and reliability. The fire pump disconnect and transfer switch should be located in a protected area that provides access to the exterior of the building. This allows for convenient operation and maintenance of the equipment. In addition, fire-rated barriers should be installed around the fire pump disconnect and transfer switch to maintain the integrity of the 2-hour fire rating. These barriers help to protect the equipment from fire damage and ensure that it can continue to operate during an emergency. In summary, a generator system that supplies power to a fire pump is classified as a legally required standby system and must comply with specific requirements of the NEC. These requirements include a 2-hour fire rated room for the generator AS, and fire pump equipment, 2-hour rated wiring for all circuits within the room and outside up to the fire pump, connection of the fire pump to the line side of the generator main, a separate fire pump transfer switch listed for the fire pump's locked rotor current, and fire rated barriers around the fire pump disconnect and transfer switch. Let's delve deeper into each of these requirements to provide a more comprehensive understanding of the NEC guidelines. Firstly, the 2-hour fire-rated room requirement as per NEC 700.9 DAN is paramount for ensuring the operational integrity of the legally required standby system during a fire emergency. The room must be constructed using materials and methods that can withstand a fire for a minimum of 2 hours, providing a safe enclosure for the generator, automatic transfer switch, and other critical components. This rating is typically achieved through the use of concrete, masonry, or other approved fire-resistant materials. The design and construction of the room must comply with local building codes and fire safety regulations. Secondly, the 2-hour rated wiring requirement extends beyond the confines of the fire-rated room, encompassing all circuits within the room and those extending to the fire pump. This ensures that the electrical pathways remain functional even when exposed to fire conditions, allowing for continued operation of the fire pump. Fire-rated wiring typically involves the use of cables and conduits that are specifically designed and tested to withstand fire exposure for a specified duration. These cables and conduits are often encased in a fire-resistant material that prevents the spread of flames and protects the conductors from heat damage. Thirdly, connecting the fire pump to the line side of the generator main is a critical design consideration. This configuration ensures that the fire pump receives priority power from the generator, regardless of the load demands of other connected equipment. By connecting the fire pump directly to the generator output, it bypasses any potential overload or fault conditions that may occur on other circuits, guaranteeing a reliable power supply for fire suppression. Fourthly, the use of a separate fire pump transfer switch listed for the fire pump's locked rotor current is essential for ensuring proper operation of the fire pump. Fire pump motors typically draw a very high inrush current when starting, which can potentially damage or overload a standard transfer switch. A fire pump transfer switch is specifically designed to handle this high inrush current without experiencing any performance degradation. It is important to select a transfer switch that is properly sized and listed for the specific fire pump motor being used. Fifthly, the installation of fire-rated barriers around the fire pump disconnect and transfer switch provides an additional layer of protection against fire damage. These barriers help to isolate the equipment from potential fire hazards and prevent the spread of flames. The barriers should be constructed using fire-resistant materials and installed in accordance with manufacturer's instructions and local building codes. In addition to these specific requirements, it is important to consider other factors when designing and installing a generator system for a fire pump. These factors may include the following. The generator must be sized appropriately to handle the load of the fire pump as well as any other legally required loads. The generator should be equipped with a reliable starting system and automatic voltage regulation. The generator should be regularly inspected and maintained to ensure proper operation. The fuel supply for the generator should be adequate to run the fire pump for the required duration. The exhaust system for the generator should be properly designed and installed to prevent the buildup of carbon monoxide. The generator system should be tested regularly to verify its functionality and reliability. Now, let's address some common questions and concerns related to generator systems for fire pumps. What happens if the generator fails to start during a fire emergency? To mitigate this risk, it is important to have a reliable backup power source such as a second generator or a connection to the utility grid. The transfer switch should be designed to automatically switch to the backup power source if the primary generator fails. How often should the generator system be tested? The generator system should be tested regularly, typically on a monthly or quarterly basis, to verify its functionality and reliability. The testing should include starting the generator, transferring the load to the generator, and running the generator under load for a specified duration. What are the requirements for the fuel supply for the generator? The fuel supply for the generator should be adequate to run the fire pump for the required duration, typically several hours. The fuel tank should be properly sized and located in accordance with local regulations. The fuel should be regularly inspected and maintained to prevent contamination or degradation. What are the requirements for the exhaust system for the generator? The exhaust system for the generator should be properly designed and installed to prevent the buildup of carbon monoxide. The exhaust system should be vented to the outside of the building and should comply with local air quality regulations. The exhaust system should be regularly inspected and maintained to ensure proper operation. What are the requirements for the maintenance of the generator system? The generator system should be regularly inspected and maintained to ensure proper operation. The maintenance should include checking the oil level, coolant level, and battery voltage, inspecting the belts and hoses, cleaning the air filter, and testing the starting system. The generator should be serviced by a qualified technician on a regular basis. Now let's examine some specific scenarios and how the NEC requirements would apply. Scenario 1 involves a building with a fire pump and a generator that is also used to power other essential loads such as emergency lighting and ventilation. In this case, the generator system would be classified as a legally required standby system, and all of the requirements discussed above would apply. The generator, automatic transfer switch, and other associated equipment would need to be installed in a 2-hour fire-rated room. The wiring would need to be fire-rated, and the fire pump would need to be connected to the line side of the generator main. A separate fire pump transfer switch would be required, and fire-rated barriers would need to be installed around the fire pump disconnect and transfer switch. Scenario 2 involves a building with a fire pump and a generator that is dedicated solely to powering the fire pump. In this case, the generator system would still be classified as a legally required standby system, and all of the requirements discussed above would apply. The fact that the generator is dedicated to the fire pump does not exempt it from the NEC requirements. Scenario 3 involves a building with a fire pump that is powered by two separate sources, one from the utility grid and one from a generator. In this case, the generator system would still be classified as a legally required standby system, and all of the requirements discussed above would apply. The presence of a second power source does not exempt the generator system from the NEC requirements. In all of these scenarios, it is important to consult with the local authority having jurisdiction, or OJ, to ensure compliance with all applicable codes and regulations. The AHJ is responsible for interpreting and enforcing the NEC and other local codes. Their guidance is crucial for ensuring that the generator system is installed and operated safely and in accordance with all applicable requirements. The information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. A qualified engineer should be consulted to design and install a generator system that meets the specific needs of the application and complies with all applicable codes and regulations. Remember that the NEC is a complex and ever-evolving document. It is important to stay up to date on the latest changes and revisions to ensure compliance. In addition to the NEC, there may be other local codes and regulations that apply to generator systems. It is important to be aware of these requirements and to comply with them. By following the guidelines and recommendations outlined here, one can help ensure that the generator system for a fire pump is installed and operated safely and reliably. This will help to protect people and property from the hazards of fire. Let's consider the specific aspects of fire-rated wiring in more detail. Fire-rated wiring, as mentioned earlier, is crucial for maintaining the integrity of the electrical system during a fire. The NEC specifies that wiring used in legally required standby systems, including those powering fire pumps, must have a fire resistance rating of at least 2 IRs. This means that the wiring system, including cables, conduits, and associated hardware, must be able to withstand exposure to fire for a minimum of 2 IRs without failing or allowing the fire to spread. Several types of fire-rated wiring systems are available, each with its own advantages and disadvantages. One common type is mineral insulated metal sheet, or MI cable. MI cable consists of copper conductors insulated with a mineral compound, such as magnesium oxide, and enclosed in a seamless copper or stainless steel sheath. MI cable is highly resistant to fire, moisture, and physical damage, making it a popular choice for critical applications. Another type of fire-rated wiring system is circuit integrity, or CI cable. CI cable is similar to standard non-metallic, or NM cable, but with added fire-resistant layers. CI cable typically consists of copper conductors insulated with a thermoplastic material surrounded by a layer of fire-resistant tape and an outer jacket. CI cable is less expensive than MI cable, but it is also less resistant to fire and physical damage. In addition to the type of cable used, the method of installation is also important for maintaining the fire rating of the wiring system. Conduits such as rigid metal conduit, or RMC, intermediate metal conduit, or INC, and electrical metallic tubing, or IMT, can provide additional protection for the wiring. Conduits should be properly supported and secured to prevent them from falling or collapsing during a fire. Fittings and connectors used with fire-rated wiring systems must also be fire-rated. These fittings are designed to maintain the integrity of the wiring system and prevent the spread of flames. When installing fire-rated wiring, it is important to follow the manufacturer's instructions carefully. Improper installation can compromise the fire rating of the wiring system and render it ineffective. It is also important to inspect the wiring system regularly for damage or deterioration. Any damaged or deteriorated wiring should be repaired or replaced immediately. Now, let's discuss the importance of proper generator sizing for fire pump applications. The generator must be sized appropriately to handle the load of the fire pump as well as any other legally required loads. The fire pump motor typically draws a very high inrush current when starting, which can potentially overload a generator that is not properly sized. To determine the appropriate generator size, it is necessary to calculate the total load that the generator will be required to supply. This includes the fire pump motor load, as well as the load of any other essential equipment, such as emergency lighting, ventilation systems, and communication systems. Fire pump motor load should be calculated based on the motor's nameplate horsepower rating and the motor's service factor. The service factor is a multiplier that indicates the motor's ability to handle overload conditions. The load of other essential equipment should be calculated based on their nameplate ratings. Once the total load has been calculated, the generator should be sized to provide at least 125% of the total load. This provides a safety margin to account for variations in load and to ensure that the generator can handle the inrush current of the fire pump motor. It is also important to consider the generator's altitude and temperature derating factors. Generators are typically derated for operation at high altitudes and high temperatures. The derating factors should be applied to the generator's rated output to determine its actual capacity under the specific operating conditions. In addition to the generator's size, it is also important to consider its voltage regulation characteristics. The generator should be able to maintain a stable voltage output under varying load conditions. Poor voltage regulation can cause problems with the fire pump motor and other connected equipment. It is also important to consider the generator's transient response characteristics. The generator should be able to quickly respond to changes in load without experiencing excessive voltage dips or surges. A generator that is properly sized and has good voltage regulation and transient response characteristics will provide a reliable power supply for the fire pump and other essential equipment. Let's shift our focus to the role of the authority having jurisdiction, or OJ, in ensuring compliance with the NEC and other applicable codes. The AHJ is the local agency or individual responsible for interpreting and enforcing the NEC and other local codes. The AHJ may be a building inspector, a fire marshal, or another designated official. The AHJ has the authority to approve or disapprove electrical installations and to require corrections to any installations that do not comply with the codes. It is important to consult with the AHJ early in the design process to ensure that the generator system meets all applicable requirements. The AHJ can provide guidance on the interpretation of the NEC and other local codes. They can also help to identify any potential problems or conflicts with the proposed installation. The AHJ may require submittal of drawings and specifications for the generator system. They may also conduct inspections of the installation to verify compliance with the codes. It is important to cooperate with the AHJ and to address any concerns or issues that they may raise. Failure to comply with the AHJ requirements can result in delays, fines, or even the shutdown of the installation. The AHJ is a valuable resource for ensuring that the generator system is installed and operated safely and in accordance with all applicable codes and regulations. They can help to prevent problems and to ensure that the system provides a reliable power supply for the fire pump and other essential equipment. Let's consider the importance of regular maintenance and testing of the generator system. Regular maintenance and testing are essential for ensuring that the generator system will operate reliably when needed. The generator system should be inspected and maintained on a regular basis, typically on a monthly or quarterly schedule. The maintenance should include checking the oil level, coolant level, and battery voltage, inspecting the belts and hoses, cleaning the air filter, and testing the starting system. The generator should be serviced by a qualified technician on a regular basis. The technician should perform a thorough inspection of the generator and should make any necessary repairs or adjustments. The generator system should be tested regularly to verify its functionality and reliability. The testing should include starting the generator, transferring the load to the generator, and running the generator under load for a specified duration. The testing should be performed under simulated power outage conditions to ensure that the system will operate as intended. The results of the maintenance and testing should be documented and kept on file. This documentation can be used to track the performance of the system and to identify any potential problems. Regular maintenance and testing will help to ensure that the generator system is ready to operate when needed and will provide a reliable power supply for the fire pump and other essential equipment. In conclusion, the installation of a generator system for a fire pump is a complex undertaking that requires careful planning, design, and execution. It is important to comply with all applicable codes and regulations, including the NEC, and to consult with the local AHA. The generator system should be properly sized, installed, and maintained to ensure that it will provide a reliable power supply for the fire pump and other essential equipment. By following the guidelines and recommendations outlined here, one can help ensure that the generator system for a fire pump is installed and operated safely and reliably. This will help to protect people and property from the hazards of fire.